Alright, so we started the class now. Let's do a quick roll call and see who all are here. So we have Rehan, Dhanushri, Chris, Neil, Ritika, Dev, Vihan, and who else? Okay, Aryan, Neil, Rehan, Ritika, Sarah, Shravya, and Vihan. Wonderful. So let's get started. So I see some of you were not there in the class yesterday, like Shravya, Ritika, and Dhanushri. But just to let you know, let you guys know that as most of you appeared for the test on last Sunday. So from yesterday we have started the second iteration of our SAT preparation, and we have started with algebra 2. So basically we started with system of linear equations, which we covered yesterday, and I have uploaded the video of the class. I have not published the link and everything. I just upload the video. I will publish the link today evening. So we'll continue with our journey on that one. But before we do that, some of you who were not in the test or who were in the test but could not share your experience with the test, let me know if there was any eye-opener for you based on the test. Meaning, how was the experience with the test? Was it good, bad, or you found everything known to you, something was not known to you, kind of thing? Okay, so I mean, you can tell me now or you can tell me offline as well. But net, our goal will remain the same. We'll do a couple of iterations of the entire syllabus, and probably we'll make sure that we focus on the things that is a little tricky, little more important, little difficult to remember. Maybe like the number system we might not cover because you all know about it very well. But everything else that is tricky or that needs a bit of thinking, we'll cover all those topics in a couple of iterations so that you guys are well prepared of that things in advance. So right now we started with the system of linear equations yesterday, and we will continue with the quadratic equations and the way to solve it. Most of you would have gone through it already, but we will see what we remember, what we don't, and we'll keep on practicing a little more. Is that okay? Or not okay?
Yes, that's okay.
Okay. So my request to you all would be, while I will keep on picking the sequence to make it work for most of you, but if any of you let's say in the coming week, if you want to pick up a different topic which is of importance for you based on your ongoing class, or anything that is kind of troubling you, which you would want to cover beforehand, just let me know. Okay. So and we'll have another test coming up in the, let's say, in the mid of January or towards third week of January. So that way again we'll learn enough and then go do one more iteration so that we get used to the test. Okay, so that way when you guys go for the SAT exam, you see that as a normal stuff rather than being any stressful exercise. Alright, so we'll start with quadratic equations one more time, and let's see what we know versus what we have forgotten. Because math is all about doing the same concepts over and over again and making sure that it's just part of the day-to-day routine. So now, when we say quadratic equation, everybody knows what is quadratic equation. Can somebody try explaining that to me? Just in layman's terms, what do you mean by quadratic equation? It could be anybody, okay? Neil, Sarah, Vihan, Ritika, Savya, Dev, anybody. Aryan. Yep, go ahead, Dev.
Is it like an equation that has like 4x values?
Say that again.
Is it like an equation with 4x values?
4x values? Did you say 4x values, Dave?
Yeah.
Okay, any other definition? Anybody else? Yeah, Aryan?
Sir, what was the question? Your voice kind of like was lagging out.
Now I was saying, can somebody tell me what is the understanding of a quadratic equation? What do you understand by a quadratic equation? Let's see what Chris has to say.
For a quadratic equation is an equation which has two x-intercepts, and its domain like goes on from negative infinity to positive infinity always.
So you guys are assuming that your teacher is very intelligent. I wanted a layman's definition. Anybody else? Audience?
It's like
Yep, yeah, we have.
it's a polynomial equation that like the x value has to go to the second degree, like the second power.
Okay. Yeah, that's a little more understandable to somebody who's not as intelligent as you would want your teacher to be. Okay. How about you, Aryan?
I don't really know like how to describe it. Like, it's, like I know like the quadratic formula, but I don't know how to like describe a quadratic equation.
Okay. Okay. That's fine. So this is what essentially we are trying to do in the class, right? When we go over the concepts over and over again, it makes all of us very familiar with the terms, how you describe it and talk about it. So now let's look at, so I heard two words, x to the power 2, and I heard another word called polynomial. So if you all remember what's happening with AI. Okay, so when you see, this is the magic of AI. When I put two fingers here, it starts blowing balloons. Okay, or flying balloons. Okay, so what is a polynomial first? Any equation which has more than one term, meaning if I have, let's say, 4x minus 7 equal to 24. Everything that is separated by the operations or the equal to sign is called a term. So here you have, this is one term, this is second term, this is third term. Same way, if I have an equation like 2x squared minus 4x plus 8 equals 0. All these are called terms, 1, 2, 3 and 4. These are 4 terms. So polynomial is nothing but a term used for representing something which has more than one term. So this will be a polynomial because it has 1, 2, 3 terms. This is a polynomial which has 1, 2, 3 and 4 terms. So any equation or an expression which has more than one term is called polynomial. Okay, it's similar to when you say quadrilateral. Every shape that has 4 sides is called a quadrilateral, whether it's a rectangle, whether it's a parallelogram, whether it's a square, whether it's a trapezium, whether it's a rhombus, whether it's a kite, right? So quadrilateral stands for any shape with 4 sides. Same way, polynomial is a term used for any equation or expression which has more than one term. So that is the polynomial part. Now, when you look at this equation and this equation, what is the difference that you see? Here, in this case, the maximum power to the variable, which is x here, is 2. Here, it's 2, 1 and probably you can say 8 into x to the power 0. So the maximum power to the variable is 2 here. This is the maximum power. So this one has power 2, and this, if you look at this equation at the same time, this has maximum power to the x as 1. So that's why we were talking about an equation which is a linear equation yesterday, where the maximum power to the variable is 1. So this is a linear equation. When you look at this equation, the maximum power to the variable x is 2, which is called a quadratic equation. Are we all on board with the definition, basic definition, understanding of a quadratic equation? If ever anybody says what is a quadratic equation, you will say that it's an equation or a polynomial, whatever you call it, where the maximum power to the variable is 2. Yeah. Now let's look at what do we want to do with the quadratic equation and why. So, like yesterday we were discussing, Aryan, you want to say something? You have raised your hand, that's what I'm asking. Okay.
Sorry.
Not a problem. I was just curious. Okay, so yesterday when we were talking about the system of linear equations, what we were trying to do essentially was that if I have two linear equations, let's say if I have one linear equation, 4x minus 2y equal to 7. When I have a linear equation, it's a linear equation because it plots a straight line in a coordinate plane. If I have two equations, let's say x plus y equal to 3, this plots another line, and wherever these lines meet, that is the point of intersection, and that follows the contract of this equation as well as this equation, so that eventually the x and y coordinate of this, the two lines where it meets, is the solution or the value of x and y, or the unique value of x and y. That's what we were discussing yesterday. Now, when you look at a quadratic equation, we will try dealing with the quadratic equation with one variable for now, and then once we get past that, then we'll talk about quadratic equation with two variables. So let's look at x square minus 4x plus 7 equals 0 as a quadratic equation. What we are trying to do with this is, we are trying to find out what are the possible values of x that we can find from this quadratic equation. That's essentially you do by solving a quadratic equation. Whether you do it algebraically or do it by plotting a graph, your purpose or the intent is to find out what is the possible solution or the values of x by solving this quadratic equation. Right? Like you were saying that, okay, if I have a linear equation draws a line, meaning there are n number of possible solutions of x and y that you can find from this one line. When you have two linear equations, that is when they meet at one point, that gives you one unique solution of x and y, or unique value of x and y. That's what we were trying to derive yesterday. So now let's see who all remembers what we have learned before, and whoever has not been in the class before but knows how to solve any quadratic equation. But before we do that, there are some generic formulas that we need to remember, and let's see who all remembers that. So can somebody tell me quickly what is the value of a plus b whole square? Anybody? Yeah, Chris.
A squared plus 2ab plus b squared.
Okay. How about a minus b whole square? Anybody apart from Chris?
A square minus 2ab plus b square.
Okay. Alright. And how about a square minus b square? Anybody?
A plus b
Times
and then whole times a minus b.
Yeah. So why we are even talking about these formulas? Primarily because these are the building blocks which helps us solve any quadratic equation for that matter. So before we go into solving any quadratic equation, let's look at some of the basic components of calculation that you guys would be knowing, but sometimes we tend to forget. So let's say if I have, let's say, minus c. If I have to multiply this with a plus b, what does it mean? What it means is this has to, if I have to kind of explode these brackets and open it up, how it will translate into is, you can do a times a plus b plus b times a plus b, and then minus c times a plus b. And again, there is nothing great about it, but I'm just trying to help all of us recollect this and see what we are trying to do. Or you can also do this times the whole thing plus this times the whole thing. Any which way you are comfortable with, okay? So these are different options when it comes to calculation. And again, if you have something like this, you can again convert into this form. If you see something being multiplied with the three terms commonly, then you can again, if you have this situation, then you can say this becomes, because a plus b is common in all the three, so it becomes a plus b minus c times a plus b. And you will say that, sir, you are wasting my time by telling me something that I already know. But the good thing is, this is something that we will use enough, a lot, while dealing with quadratic equations. So that's why it's very important to do a recap on that. Okay? So far, everybody with me, or anybody wants to stop me and ask something? Everybody with me? Now, if I have any now going back to the point that I was making, that there are three basic formulas, a plus b whole square, a minus b whole square, a square minus b square, that we need to memorize like A, B, C, D. Okay, that should be part of our, what you call, I call it muscle memory. Yeah. So why? So because if I'm trying to solve a quadratic equation, my first attempt has to be to look at the quadratic equation, see, is it something like a plus b square whole square? Is it relating to a minus b whole square, or is it something relating to a square minus b square? The reason being, if I am able to convert any equation to this form, then I get the solution immediately. So let's look at one situation real quick. If let's say, if somebody says, solve this quadratic equation to find out the value of x, and my quadratic equation is, let's say, x squared minus 16x plus 64 equals 0. And if you're trying to solve this, the first attempt that you should make is it a plus b whole square? No, a plus b whole square has all positive. Is it looking something similar to a minus b whole square? Let's see. If my x is equal to a, then this is 2 times a times a. So this could be my potentially b, because a minus b whole square is nothing but a squared minus 2ab plus b squared. So if x is my a, I have a squared. This is fine. Now this part, 2 into a into 8. This is how I can split 16x into 2 into 8 into x. So this could be my potentially b. Now this square of this 8 square of 8 is nothing but 64. So what we see here is, this is a minus b whole square form. So immediately, without doing much of a calculation, as long as you are able to quickly relate it with one of the generic formulas that we talked about, then you'll say, oh yeah, this is x squared minus 2 into 8 into x plus 8 squared. So this is a squared minus 2ab plus b squared. So this is nothing but x minus 8 whole square. So this quadratic equation became this. Or you will say, okay, fine, this is x minus 8 into x minus 8. And this might look stupid, that I already got this, why I'm kind of again splitting this. Because whenever you're trying to solve any quadratic equation, your ultimate goal is to factorize it. Convert it into two factors. So that way you will say, okay, either this is equal to 0 or this is equal to 0. Good thing is both are same, so you have only one situation which says x minus 8 equals 0. Both are relating to one term, so x equals 8. So in this case, this quadratic equation has only one solution, and you got a solution for x, which gives you x equals 8. Am I making sense so far? Am I going at the right pace? Neil, Sarah, Chris?
Yes.
Okay. Okay. Ritika, Shravya, everybody with me, right?
Yes, sir.
Okay. Alright. So this was just one example where we just looked at this one. Now, let's look at another situation. If I, on the similar lines, if I say, find out x squared minus 6x or x squared plus 6x plus 9. Immediate thing that will come to your mind is it a plus b whole square? Because there is no minus, so it could be a plus b whole square. If x is my a, 9 is what? 9 is 3 squared, and I have a squared plus b squared. Is this 2ab? 2 into a into b into 3? Yeah, this is matching. So immediately you found that, okay, fine. This is x plus 3 whole squared, which means this, and I have only one solution here. So x equals x plus 3 equals 0. See, when you are multiplying two things, gives you 0, that means either this is 0 or this is 0. So this is one solution, this is one solution. Both are same here. So x plus 3 equals 0, so x equals minus 3. So you got this one. So that generic formula, if you remember, you can quickly validate your quadratic equation to try solving it. But life is never so very easy. Let's look at something little more interesting. Now, if I say that, okay, fine, x squared, let's look at another situation. 4x squared plus 32x plus 64 equals 0. Now, this is not a square plus b square form that you can see straight away. So, but what you see is, I have, see this, if 2x you treat as as a, this is a square. So here 2, and what is 64? This is 8 squared. And so 2x is your a, 8 is your b, and then so 2x, okay, so 2ab will be 2 into 2x into 8. Okay, so this one is matching. So I kind of got trapped in my own question. Let me change the question a little bit. What if I say 3x squared, okay, plus 24x plus 48. If I had this situation, this is certainly not, you cannot convert this to a plus b square because this is not a square, okay, by any means. So, but then what you see here is, you can take a 3 common and then becomes, then this is a plus b whole square. So basically, if it's a straightforward a plus b whole square, that is fine. Or else, as I was talking about yesterday, that if you have an equation, a linear equation like this equation and anything multiplying this whole equation are the same, okay? There is no difference. So same thing applies for quadratic equation also. So if you see that you have a quadratic equation and you can take something common out, you might want to do that to simplify the equation, and then you try attempting solving it. Okay, so this is the first part of it, where you're trying to use the generic formulas for solving a quadratic equation. Any questions so far? No questions? So multiplying an equation or dividing an equation with a number doesn't change the equation, be it a linear equation, be it a quadratic equation, or any form of equation. Okay, so that remains the same. So you can take the common things out and then try solving it for the value of x. And just because you have a common multiplier for all the terms, that doesn't change the overall solution of the equation. Is that okay so far? Okay. Now I was saying that life is not very easy, and it's not supposed to remain that easy. It's our job to make it simpler. So let's see how we can do so. So now let's look at another equation where I'm trying to solve for x squared plus 7x plus 6 equals 0. Okay. Now it doesn't look like a minus b whole square for sure, because all terms are positive. But does it look like a plus b whole square? Can somebody tell me yes or no? No, because this is not a square. 6 is not a square for sure. Yeah. So now I cannot relate it with a plus b whole square. Does it mean I will leave this question? There is a second approach for solving it. Now let's see who remembers in the class how to solve this kind of equation. What is the second approach? If it is not a perfect square, if you cannot relate it to the generic formula, how you would want to solve it?
Quadratic equation or form.
Without going there. There is a second approach. AB, A plus B. That's what I call it. Yep, yeah, Ritika.
So it's when you like trying to find two numbers that multiply to 6 and add to 7.
Right. So that's what. So now what we want to do is just take a step back. Like when you look at a linear equation, you can always look at the standard form of the linear equation as plus c equals 0. So this is a standard form of a linear equation. Similarly, you can always represent the quadratic equation also in a standard form, which is called ax squared plus bx plus c equals 0. So this is a standard form. So basically, if you relate this equation with this one, your a is 1 here, b is 7 here, and c is 6. Yeah. Now, what you have to do is, there's a trick for doing so. What you can do is look at your a. Here in this case, a is 1, and look at your c, which is 6 here. Simple thing that you want to do is multiply a and c, which gives you a 6. Now look at what are the possible factorization you can do, meaning how you can write 6. You can write 6 as 6 into 1, 3 into 2, and there is no third option. Yeah, these are the ways you can factorize it. Now you look at the b part of it. If your b can be one of these factors, then you have a solution. Meaning 7, if you look at 6 and 1, if you add these two together, that gives you a 7. That means you can split this 7 into two parts as 6x plus x, and that helps you move on. So again, as I said, you have to multiply a and c, look at the values, then you try factorizing it and see how you can add these two factors to get a b, if there is a possibility. So here in this case, if you look at this equation, all that we did was a behind the scene calculation. Okay, so this simply tells us that I can break 7x as 6x plus 1 plus x plus 6 equals 0. Now you can take two terms together, first two and the last two. Here in these two, what is common? That is x. So this becomes x plus 6 plus, here it is x plus 6, which you can as well write as this. Yeah. Are you with me so far? I'm going very fast. Or let me introduce one extra step. Let me do some manual labor a little bit. So this is what I'm doing right now. So whatever value I had, I just put them together. Okay, in a group of two terms. Okay. Now between these two terms, we see that x can be taken out as a common stuff. X plus 6. This becomes x plus 6. Now in this one, there is nothing common, but I can always say 1 times x plus 6. Yeah. Now if you go back to what I was doing a little bit ago, I was saying that if I have something common, I can club them together because this and this are common, right? So this becomes x plus 1 times x plus 6 equals 0. So this was our ultimate goal. Like I said, whenever you're trying to solve a quadratic equation, your ultimate objective is to come to a point where you can write that as two factors. Okay? Basically, you're factorizing the quadratic equation. Earlier, you had a way to map it with a plus b whole square, or a minus b whole square, or a square minus b square form. Now, that trick did not work. So, we looked at another way to get to that point. Now, this one says, okay, fine. Either this is 0 or this is 0. So, there are two possible solutions. When x plus 1 equal to 0, gives me x equals minus 1. When x plus 6 is 0, then it gives me another solution is x equals minus 6. Yeah. So, I know you guys already know these things, okay? But sometimes we just do a recap to make sure that we don't miss on some of those interesting aspects of how you deal with those calculations. Is everybody with me so far? Vihan, are you able to follow me, beta?
Yeah.
Okay. So far whatever we have done, we have looked at two techniques for solving a quadratic equation. First technique is you look at the quadratic equation and then kind of see if you can map it with one of those generic formulas, a plus b whole square, a minus b whole square, or a square minus b square, and then that gives you a factor, two factors which you can use for solving it. If you cannot relate it with the generic formula and you have a situation like this, then you check that okay, if I multiply a and c, whatever value I get, look at the factors of that and can I use those factors to split this? And this is how we solve it. So let's do one thing. I would want you guys to get your hands a little dirty and try solving it real quick in next 5 minutes before I go to the third approach. So any problem, every problem in math that you come across, there will be multiple ways to solve it. So we are just trying to explore all those possible options so that we can choose among them which one works best for us. Yeah? Okay, now let's try solving it. X squared minus 14x 2x squared minus 14x plus I want you guys to try solving it and tell me what are the answers for x before we move to the next part of the class. Can I request everybody to try it? You guys have 5 minutes to solve it. Can I assume everybody is trying? Somebody has to say yes. Okay. Yes, Chris.
So I got x equals 3 and x equals 4.
3 and 4. Okay. Okay. Yeah, Ritika.
I have the same answer.
3 and 4. Okay. How about you, Aryan?
I got the same answer, sir.
Not good. Everybody giving same answer. You guys are not very diverse. Okay. Vihan, are you trying to?
Yeah, I just now finished it.
Okay. Very good. Did you also get the same answer?
Yeah.
Okay. Sarah, Neil, Dave.
I have the same answer.
Okay. Shravya,
Yes, sir.
Did you get the same answer?
Yes.
How about you, Dhanushree?
Same answer.
Very bad. Everybody giving same answer. But again, same approach. This is my A, this is my C. So I will do 2 times 24, that gives me 48. And the first thing I'll do is 48. And how do I factorize? 1 into 48, 2 into 24, 3 into 16, 4 into 12, 6 into 8. I think that's all. Now I will look at the options. So I have to get 14. This is my best bet. So that means I can split this into 6x and 8x. And again, let's be careful with the sign. So this becomes 2x squared minus 8x minus 6x. And the beauty of this is you can put minus 6x before or 8x before, doesn't matter. You'll get the same answer. Okay? As long as your splitting is fine, you will not get anything wrong. Pick first two. Let's see. When you're picking up these two, what is common? 2x is common. So you take 2x here. You get an x here minus 4. And here, what is common? Minus 6 is common. So you take minus 6 out, it becomes x and minus 4. So which essentially translates into 2x minus 6 into x minus 4. And then when this is 0, 2x minus 6 equals 0. So x equals 2x equals 6 or x equals 6 by 2, which is 3. And when this is the case, then x equals 4. And again, you must be thinking that why sir is taking so much time and doing every step. Because I would want you guys to practice that, okay? When I saw the test paper from you all, I saw that everybody was leaning towards giving the answer. But just looking at the answer doesn't create enough excitement for me. I always look for how you are solving it. So when you have a question to work on, in the question paper on the side, I would want you to write at least few steps. So that gives me the confidence that yes, you have not just solved it in your mind. I mean, when you do things step by step, that not only gives an opportunity to me to see if you are doing it the right way, but at the same time, if you guys get to that practice, it will also help you with the review. Because once you finish the test, if you have some time, you certainly would want to go back and see what you did and where you could have, where you might have gone wrong. So this, if you're writing the steps, it helps you do the review. Again, take a call how you want to optimize your time. Obviously, you would not want to write all little steps like I'm doing, but then when you kind of at least write the minimal steps, that helps you review, at least to determine or investigate what could be going wrong. You will have a way to refer. If you just focus on writing the answer without taking any notes, you would not know why something went wrong or did not go wrong. Okay. All right. So this is the second approach. So first approach was mapping it, your equation with a generic formula, if that is possible. And second approach was splitting, looking at A and C, multiplying them, and looking at how you can use the factor of A and C to get a B, right? So that's what I call it. AC equals A plus C. That's what I call it. I mean, you can call whatever you feel comfortable with, but this is the second approach. Now, if both are not working, what do you do? There is a magic wand. There is a formula. But before I go to that formula, so now based on whatever we have seen, the first scenario when we were able to relate any quadratic equation to a generic formula like a plus b whole square or a minus b whole square, we were able to get only one answer. Okay? But when we were able to split that into two parts, like the second approach, we got two answers. So remember that whenever you are solving a quadratic equation, you can get up to two answers. It could be one answer or it could be up to two answers. Or third scenario is obviously no answer. So we'll look at what are those possibilities and when do we come across that. So when we look at the third formula or third method, which is called the method of discriminants. So, can somebody tell me what is a discriminant? I mean, how do you use it? If anybody remembers the formula. Does anybody remember saying that, okay, if I have an equation like x squared minus 2x plus 6 equals 0. Yeah. If I, so see this one is not, this is not squared, so this is not a minus b whole squared for sure. Neither when you multiply a and c, this gives you 6. Now what are the factors of 6? 6 into 1, 2 into 3. None of these by adding or subtracting or whatever magic you want to do will give you a 2. 6 plus 1 or 6 minus 1 gives you a 5, 2 plus 3 gives you a 5, or 3 minus 2 gives you a 1. So you cannot use this method also. Then there is a third method which is called the method of discriminant. And does anybody know? And that method is totally based on one formula, which I call as a magic formula. Does anybody remember that? Okay, I mean, I'm sure you guys know it. So when you relate your quadratic equation with the standard form, which is nothing but ax squared plus bx plus c equals 0, this says that you can just apply this formula to find out the two solutions of x. And this method, this part of the thing is called discriminant. Now before we go into this, if look at the situation when this value is 0, what will happen? So okay, let's say this is, I'm just using a term b squared minus 4ac as a d, okay, discriminant. I don't know if I'm pronouncing it right. You guys might say something different, but it's called discriminant is what I know. If there is a different pronunciation, please excuse me for that. So this, my d is nothing but square root of b squared minus 4ac. Now if you look at this equation, if I replace this with a d, it becomes minus b plus minus d by 2a, where b is nothing but my coefficient of x, a is my coefficient of x squared, and this d is nothing but the calculated value of b squared minus 4ac square root. Okay. Now when d is 0, what will happen? When d is 0, you will have only one solution, which will be x equal to minus b by 2a. When d is a value greater than 0, let's say you get d equals 1, then you will have two solutions. One solution will be minus b plus d by 2a, or let's say the value of d is 1. And second solution for the, or second value for x will be minus b minus, plus and minus, right? So b minus 1 by 2a. So these are two answers that you will get. And so far we are just assuming, we have not done any calculation so far. But what I am trying to come to is, this guy d determines whether you will have one solution when the d is 0. This part becomes 0, then you have only one solution for x. When d is greater than 0, then you have two solutions, one with a plus, one with a minus. And when d is, let's say when this value is negative, no, b squared minus 4ac is negative. This is called imaginary number. Square root of a negative number is called an imaginary number. So that means you will not have any solution for this. This value of d is imaginary, so you cannot solve it. So basically this value of d, b squared minus 4ac square root, is called discriminant because this differentiates the solution. If this is 0, only one solution. If this is greater than 0, there are two solutions. If this value is square root of negative, there is no solution. So this guy discriminates all the answers, and it's called discriminant. Okay, so I mean that's one way to remember it. I know there is no discrimination happening here, but the term discriminant is alluding to that point where it says, okay, fine, this guy will differentiate or discriminate all the answers, and that's why it is called discriminant. Are you guys with me so far, or I'm just trying to teach myself? Is everybody with me? Savya, Vihan?
Yes, sir.
Okay, Dhanushri?
Yes, sir.
Okay. So, now let's come back to this guy. So, we said that if I have a quadratic equation, I don't have to worry about anything. I don't want to waste my time doing all the calculation. I just remember one formula and I'll use that. Let's see. My formula is x equals minus b plus minus b square minus 4ac by 2a. Now, what is a? Here a is 1. What is my b? B is minus 2. What is my c? C is 6. Let's put it here. In this formula. So x equals minus b. So minus of b. Okay. Plus and minus b square minus 4ac. So b square is what? Minus 2 square. Minus 4 into a is 1 into c is 6. Divide by 2 times a is 1. Now see what has happened here. So this is minus into minus 2, minus into minus plus 2 plus minus b square is 4, minus 2 square is 4, minus 4 times 6, 24 by 2. What happened here? You got an imaginary value here, because this is the square root of minus 20. So when you have a situation like this, you know that now I cannot proceed further because there is no solution. I cannot solve this quadratic equation. That is why when you are dealing with this formula, the first thing you do is this. You will say, let me see if it is actually worth solving it. I will not do the whole calculation. Let me find out the value of discriminant. What is my value of discriminant? That is nothing but square root of b square minus 4ac. And as soon as you saw this, minus 2 square minus 4 into 6 into 1. Oh, I got minus 20. There is no solution for this quadratic equation. I cannot solve this. I mean, as in nobody can solve this. Yeah? So that's why when you are dealing with this formula, this is your first attempt. Had it been a plus, we had a solution for this. So then this would have been no, my bad. Even if it was a plus, there was no solution for this. The only way we could have solved this, if this was a plus or minus, whatever, and let's say this was 8, then that would have become 8 squared, 64 squared into 4 into 6. 64 minus 24. You would have got 40, and then at least, even if it becomes this is not an imaginary number. Negative of square root is considered an imaginary number. You cannot find out the square root of an imaginary number. Sorry, square root of a negative number. As long as the number is positive, this will have some value. And you can, since you guys are allowed to use calculator, you don't have to break your head to find out the exact value by doing manual calculation. You can use calculator and find it out. But the summary is, there are 3 ways in which you can solve a quadratic equation. First method is, you just look at a quadratic equation, see if you are able to relate that with any other generic formula, and then try solving it. Second method is where you use that a times c value and see the factors of that gives you a b by adding or subtracting. And then the third is the called method of discriminant. Okay, so want to know if whatever we have learned so far, is there any doubt, confusion, anything that is bothering you guys, anything that is not clear? Dave, Chris, anybody? Aryan?
That makes sense.
No, sir.
Everybody clear? Now, see, so when we learn math, right, I mean, people say math is not like a story. My problem is, I tend to make it like a story. Now, look at what we have done so far. Let's look at the journey part of it. So that way, you will always be able to stitch things together and see how you relate and how do you use it actually in your day-to-day thing. Now, we started with the first definition where we talked about what is polynomial. If I have any equation, regardless of how much power it has, if I have more than one term, meaning two values, two terms separated by an operation or equal to sign, is called polynomial. Then we looked at the linear equation. When we looked at the linear equation, that you would have noticed that we were dealing with two variables. And then we looked at linear equation draws a line. If I have two lines, two linear equations, how I can use graph, how I can use algebra for solving it. And then we also looked at how that ratio of the coefficient helps to determine whether the lines are going to coincide, are going to be parallel, or going to be intersecting each other. So if they are going to intersect, if by the look at the ratio, if you are able to determine if they are going to intersect, then you will try solving it for x and y using method of substitution or method of elimination. Then we said, okay, fine. Now we look at linear equation. Let's go to quadratic equation. But what did we do? Here we were dealing with two variables. Now I said, okay, no, I don't deal with two variables. I'm dealing with one variable. Where did y go? We are only dealing with one variable right now. This is when the next step in the journey would be where we will talk about okay, let's not touch this one. I'll call this parabola. This is where we will say, okay, fine, this is not 0. Y or function of x, whatever you call it, and this will become parabola. So look at the journey. So we start with linear equation, quadratic equation, then we'll start with parabola in the next class. And when we deal with parabola, we'll again talk through how does an equation for parabola come into existence. How do we use that for drawing in a coordinate plane, and then how do we deal with the coefficients? How do we manipulate them for making the parabola move or derive different interpretation out of it. So that will be our plan for the next class. I will let you guys think and let me know if there is something that is confusing or something that you would want to talk about now before I let you guys go.
Wait, is this our class?
You want to learn parabola? Okay. If no other questions, if you guys are comfortable, I'll give you guys 5 minutes back and use that time for settling down for the next class. And we'll start with parabola in the next class. Yep. Alright. So we'll have one more class on next Saturday. And after that I will go on break for 3 days. Meaning I'll be away from 22nd till 2nd of January. So we'll not have any class in the last week of the month. 2nd of January, I said.
No, you said 32nd December.
I never said that. So anyways, if I said so, ignore it. So I said I'll be gone on 22nd of December. I'll be back on 2nd of January. So
22nd?
okay, let these kids go, okay? If we start in a discussion, then it'll get more interesting. Alright, so we'll have one more class on next Saturday, and then from we'll not have any class for the Sunday post that, and one last week of this month. Okay?
Wait, is it Sunday and then Saturday
Alright. Thank you everybody and see you guys on next Saturday.
Bye, sir.
Bye bye.
Thank you.
Bye bye. Bye bye. Bye
Is it
bye.
also for us?
Bye, sir.
Bye bye. Bye bye.
If he's taking a break, you think it's just going to.
What do you want? Tell me. Hey Vaishu.
Hey.
Okay. So we'll give couple of minutes to everybody. You guys have joined a little bit early and then we'll start.